Rajim. Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Class 10, subject physics, chapter number 11, sound. We were discussing problems as we have done first four problems 11.1, 11.2, 11.3, 11.4 in our last lecture. For today's lecture, we will discuss problem 11.5, 11.6, 11.7, and 11.8 and 9. These problems are on page number 35. This is the chapter we were doing. As we have finished this chapter, we were number 11. 11 chapter is regarding the sound. 11.5, problem number 11.5. If you open page number 35 of 10th class textbook, you will, I read the statement of the problem number 11.5. A marine survey ship sends the sound wave straight to the seabed. It receives an echo 1.5 seconds later. The speed of sound in sea water is 1500 meters per second. Find the depth of sea at this position. I repeat, a marine survey 11.5 on page number 35, 10th class textbook. If you open page number 35, students, 11.5, I am reading the numerical statement for chapter number 11, page number 35, 11.5 numerical. A marine survey ship sends sound waves straight to the seabed. It receives an echo 1.5 seconds later. The speed of sound in sea water is 1500 meters per second. Find the depth of the sea at this position. So in this numerical, which is what is given to me, time to hear echo, that is t is equal to 1.5 seconds. Time to reach the seabed, it takes one side. That's why I'm dividing this with 2. So time to reach the seabed, t divided by 2, 1.5 divided by 2, you will get 0.75 seconds. It will be the one-way time. So echo will come two-way. If it goes and then come back, that is two-way. But we divide this two because it is a one-way time. Time to reach the seabed, t divided by 2. Whatever the time over here, 1.5, you divide this by 2, you will get time for one time, or the only single time, 0.75 seconds. Speed of sound is denoted with v, which is given to me. Speed of sound in sea water is 1500 meters per second. So to find what I need to find the depth of the sea at this position. Depth of sea is denoted with S or H equals to S. You know the formula as we have done in chapter class 9. For this formula we have discussed in class 9 as well. S is equal to Vg. If you use this formula, you can find the depth of sea depth, and depth of sea. V is 1500 multiplied by 0.75. V is 1500 multiplied by 0.75, one-way time, okay? 1500 multiplied by 0.75, you will get 1125 meters. So depth of sea at the position will be 1125 meters. I repeat, this numerical 11.5 is on page number 35 of your 10th class textbook. I read the numerical statement first. A marine survey ship sends the sound wave straight to the sea bed. It receives an echo 1.5 seconds later. The speed of sound in sea water is 1500 meters per second. Find the depth of the sea at this position. So time to hear echo t is equal to 1.5 seconds. Time to reach the seabed t divided by 2 is equal to 1. You divide this 1.5 seconds divided by 2, you will get 0.75. Speed of sound is denoted with v, and it is given to me 1500 meters per second. Depth of sea is we need to find out. So we have the formula S is equal to Vt. So S is equal to Vt, we just put the values. V is equal to 1500 and time is, which I found, 0.75. If you multiply this 1500 multiplied by 0.75, you will get 11,000, 1,125 meters, which is the depth of the sea at its position. So I move towards next numerical, which is 11.6, which is again on page number 35. I'll read the numerical statement first. 11.6, a student clapped his hands near a cliff and heard the echo after 5 seconds. What is the distance of the cliff from the student? Is the speed of the sound is taken as 346 meters per second. I repeat, a student clapped his hands near a cliff and heard the echo after 5 seconds. What is the distance of the cliff from the student if the speed of the sound is taken as 346 meters per second? What is given in this equation, in this problem? Time to hear echo, it goes and it comes back, that is called two-way time. This is given two-way time, 5 seconds. The boys clap and after reflection, uh, the same sound will come back to, he can hear the echo after 5 seconds. So it is a two-way time, right? 5 seconds is a two-way time. Time of sound to reach cliff, so it is a single time. So what is the 5 divided by 2? You will get 2.5 seconds. This is the single time we are required. And speed is given to me 346 meters per second. This is also given. If the speed of the sound is taken as 346 meters per second. So speed is given to me 340 seconds. Again, I need to find the distance or distance from the distance of the cliff from the student. What is the distance of the cliff from the student? This is the distance we need to find out. We use the formula S is equal to V2, S is equal to V times T. This is the formula we have discussed in class 9, chapter 3 or 4. I don't remember at this time. So S is equal to Vt we have already discussed. When we discussed the equations of motions, we discuss this formula S is equal to Vt. Use the same formula in this equation to find the distance. So V is 346 and take the 2.5 single time that will that is the distance from cliff to the students. Students. So 346 multiplied by 2.5, you will get, if you multiply this 346 multiplied by 2.5, you will get 865 meters. So this is my distance from the cliff to the students. Next, 11.7 problem. I repeat, I read the statement of this numerical. A ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of ultrasound through seawater is 1531 meters per second, what is the distance of the seabed from the ship? So I repeat, a ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of the ultrasound through seawater is 1,531 meters per second, what is the distance of the seabed from the ship? So what is given to me in this equation? Time of detection of sound, that is noted with small t, which is 3.42 seconds. Time of sending sound, so only one, as we discussed earlier two numericals, I divide this with two, the time, which is the two-sided timing. So I divide this to get one side time. 3.42 divided by 2, 1.71 second is the one-way time required. Speed of sound is V is equal to 1531 meter per second. Distance we need to find again. I will use the same formula. S is equal to Vt. V is 1531. This is 1531. Multiplied by time. Time is 1.71. If you multiply 15,531 with 1.71, S is equal to 2618, which is the distance which is required. The result is distance 261 meter, and you know the distance, unit of distance is meter. Again, time of detection of sound, students, this is the two-way time. 3.42 second. Time of sending sound is divided 3.42 divided by 2. 1. If you divide 3.42 divided with 2, you will get 1.71 second. So speed of sound is also given to me 1531 meter per second. So what I need to find out in this numerical, what is the distance of seabed from the ship? So we need to find out the distance from seabed to the ship. So it is the only one way. So speed of sound is v is equal to 15 15 as 31. So s is equal to vt. So I will use the time, which is divided by 2, which is 1.7. I will not use this one. This is the two-way time. I will use a single time 1.71. So 1.71 multiplied by 15, 1531. You will get 2618, which is the distance of the seabed from the ship, which is the required result. So I'm moving towards now 11.8 numerical. So student, I read the statement for you first. The highest frequency sound human can hear is about 20,000 hertz. What is the wavelength of sound in air at at this frequency at a temperature of 20 degrees Celsius? What is the wavelength of the lowest sound we can hear of about 20 hertz? Assume the speed of sound in air is 20 degrees Celsius is 343 meters per second. I repeat, this numerical 11.8 is on page number 35 of your 10th class textbook. If you open page number 35 of 10th class textbook, you will find this 11.8 numerical statement. The highest frequency sound human can hear is about 20,000 hertz. I already told you when we discussed the topic. The audible frequency range is 20 hertz to 20,000 hertz for the human human being. Human being can hear minimum sound is 20 hertz and the maximum sound level they can hear is 20,000 hertz. As we have already discussed in when we discussed the topic audible frequency range. So the highest frequency sound human can hear is about 20,000 hertz. What is the wavelength of sound in air at this frequency at a temperature of 20 degrees Celsius? What is the wavelength of the lowest sound we can hear of about 20 hertz? So this is 20 hertz is the lowest one and 20,000 is the highest one. Assume the speed of sound is, and the speed of sound is given to me 343 meters per second. So I will write the data now. Given data, highest frequency, 20,000. Let's say I denote F1 as the highest frequency and the lowest frequency I denote take it as F2. I take the highest frequency as F1, which is 20,000 hertz, which is given to me, and the unit of frequency is hertz. Lowest frequency is F2, which is also given to me, which is 20 hertz, and the unit of frequency is again hertz. And this is the audible frequency range because human cannot hear less than 20 hertz and cannot hear more than 20,000 hertz. So he can hear between the 20 hertz to 20,000 hertz. This is called audible frequency range, as we have already discussed this when we read the topic audible frequency range. Speed of sound, it is also given to me. V is equal to 343 meters per second. Given to me. If you assume the speed of sound in air at 20 degrees Celsius, 343 meters per second. This is given to me. To find what we need to find wavelength of the highest sound. Wavelength, is notable lambda. So since it's the highest for highest sound, I take it as lambda 1. For the lowest sound, I will take it as lambda 2. Okay, these two things are required. And this formula V is equal to F lambda. Since I'm for the highest, I'm finding out wavelength for the highest sound, so that's why I'll take it as F1 and F1 and lambda 1. F1 and lambda 1. If you separate this out, lambda 1 is equal to, if this is multiply, if it goes down, it will be divided. So V divided by F1, lambda 1 is equal to V divided by F1. Just substitute the value. V is, 343 meters per second. And F1 is, I'm taking, since I'm finding the wavelength for the highest sound, that's why I'm taking lambda 1. and I'm using the f1 for the highest. F1 is 20,000. I'm putting 20,000 hertz. If you divide this 343 with 20,000, you will get 0.01715, and the unit of lambda is meter. Lambda meter is the unit of lambda. So if you move this point, if you write this one into scientific notation, 1, 2, so that's why 1.7 into 10 power minus 2 meter is the length, lambda 1. Okay. So this is, we found wavelength of the highest sound. We have found wavelength of the highest sound for the frequency f1 when the frequency is 20 hertz, 20,000 hertz. Now we find the wavelength of the lowest sound, which I said lambda 2. So I will use the same formula, but this time V is equal to F2 lambda 2. I will take frequency F2. I will take frequency F2 because I am finding the wavelength of the lowest sound. So V is equal to F2. I will take the lambda 2. I will take it lambda 2. I separate out lambda 2, V divided by F2. So just plug in the values. V is equal to 343. So V is equal to 343 divided by 20. So if you divide this 343 with 20, you will get 17.15 meter. So result will be lambda 1 is equal to 1.7. Lambda 1 we just found 1.7 10 power minus 2, and lambda 2 is we found 17.15 meter. So this is the end of the numerical 11.8. I repeat this numerical for you again. The highest frequency sound human can hear is about 20,000 hertz. What is the wavelength of sound in air at this frequency at a temperature of 20 degrees Celsius? What is the wavelength of the lowest sound we can hear of about 20 hertz? Assume the speed of sound in air is 20 degrees Celsius is 343 meters per second. So highest frequency sound human can hear is 20,000 hertz. You know the highest frequency sound human can hear is 20,000 hertz. So highest frequency is given that f1 is 20,000 hertz. I say highest frequency is noted with f1 and the lowest frequency is noted with f2. So f1 is 20,000 hertz and f2 is 20 hertz, and you know the 20 hertz and 20,000 hertz is the audible frequency range which can human being can hear. So when we read the topic audible frequency, we discussed about lowest frequency that a human can hear is 20 hertz, and he cannot hear less than 20 hertz, and he cannot hear more than 20,000. Which means 20 hertz to 20,000 hertz, near 20 kilohertz are the audible frequency range of human being. Speed of sound is given to me, V is equal to 343 meters per second. What we need to find out wavelength of the highest sound. Let's say wavelength of the highest sound is lambda 1, and wavelength of the lowest sound is denoted with lambda 2. So we read this formula, V is equal to F lambda. So we discussed this formula, and as we already know this formula, V is equal to F lambda. I'm just putting F1 lambda 1. Why? Because I want to find out the wavelength in first case and the wavelength for the wavelength of highest sound and wavelength for the lowest sound. So wavelength of the highest sound is noted with lambda 1, and lambda 1 where frequency is 20,000, and wavelength of the lowest sound is lambda 2 and its frequency is 20 hertz. That's why I'm just separating out lambda 1 is equal to V over F1. V is 343, V is 343, and F1 is 20,000 hertz. So if you divide 343 with 20,000, you will get 0.01715. So if you shift this into scientific notation, since we are coming from left to right, so how many points we are moving? 1, 2, it's mean 10 is power minus 2. The minus 2 indicates that we are moving from left to right. So lambda 1 is 1.7 into 10 raised to the power minus 2 meter, which is the wavelength for the highest sound. Now I move towards wavelength of the lowest sound. Wavelength of the lowest sound is noted with lambda 2. So again, I will use the same formula, V is equal to, but this time F2 multiplied by lambda 2 because I want to find out the wavelength for the lowest sound, and the wavelength for the lowest sound is the lambda 2. To separate out lambda 2, so V divided by F2. So since I will put F2, I will not put 20,000, I will because I want to find out the lambda for the lowest frequency. That's why I will put 20 hertz. So 300 speed will be the same. Speed will be 343 divided by 20. In this case, 17.15 meter is the wavelength of lowest sound. Wavelength of the lowest sound. So lambda 1, my result will be 1.7. Lambda 1 is 1.7 into 10 to the power minus 2 meter. Meter is the unit of length. Lambda is the wavelength. Wavelength is the unit of wavelength is meter. So lambda 1.7 into 10 to the power minus 2 meter, and lambda 2 is 17.15 meter. Okay, this is the end of the problem 11.8. Now we move towards last problem, which is 11.9, again on page number 35 of your 10th class textbook. I read the numerical statement for you. A sound wave has a frequency of 2 kilohertz and wavelength is 35 centimeter. How long will it take to travel 1.5 kilometer? Again, a sound wave has a frequency of 2 kilohertz and the wavelength is 35 centimeter. How long will it take to travel 1.5 kilometer? So frequency in this case is a frequency, it is noted with small f, and frequency is given to me 2 kilohertz. So 2 kilohertz, 2 kilo mean 1000, kilo mean 1000. So if you multiply by 2, multiply by 1000, so you need to convert this frequency into SI, which is the unit of frequency is hertz. It is a bigger unit. It is a unit of kilohertz, is a unit of frequency, but this is a bigger unit. But we need to convert this into standard one, SI unit, which is the frequency unit is hertz, 2000 hertz. We have converted into standard one, 2000 hertz. So wavelength is given to me 35 centimeter, as you can see in the numerical 11.9. The wavelength is 35 centimeter. Again, centimeter is the smaller unit of length, but we need to convert this into SI unit, and SI unit of the length is meter. Again, what will you do? You will divide this 35 with 100. Centi is 100. So if you divide this centi is 10 to the power minus 2. If you take this 10 to the power minus 2 at the bottom, it will be 10 to the power plus 2. And when you divide 35 divided by 100, you can get this 0.35. Move this point 1 to how many points? 1 to 1 to 0.35 meter will be the standard unit of the wavelength. Meter is the standard unit of the wavelength. Distance is also given to me 1.5 kilometer, and again I need to convert this into meter because SI unit of our distance is meter. So 1.5 multiplied by 1000, you will get 1500 meter is the distance. 1500 meter is the distance. So to find in this case, time is how long? How long you need to find out time? How long it will take to travel 1.5 kilometer? So time we in this numerical time is required. So I will use the formula. First of all, I will use the formula V is equal to F lambda and find V from here because V is not given to me. To find T, uh, we need velocity or speed. So how will I can? I'll just put the value. Frequency is 2000. Frequency is given to me 2000, and the lambda is given to me 0.35. If you multiply by 2000, multiply by 0.35, you will get 700, and the unit of speed is 700 meter per second. Unit of speed is meter per second. Again, I use the formula S is equal to Vt, and we need to find out the T. That's why I separate out T from this equation. So V is multiply here. If it is go on the other side of the equation, it will be divided. S divided by V. So S value is 1500. Look, the value of S is 1500, and the value of V we just found 700 meter per second. So just plug in the values 1500 divided by 700, you will get time. And if you divide 700 will be divided with 1500 will be divided with 700, you will get 2.1, and the unit of time is second, and time is 2.1 second is our required result. This is the end of the numerical 11.9. I repeat 11.9 numerical. Now, a sound wave has a frequency of 2 kilohertz and wavelength
अब मैं मेरी अम्मी है आपका
and wavelength is 35
आपका
centimeter.
मुझे कुछ कहना बनता है
How long
उसका
will
मुझे
it
कुछ
take
कहना
to
बनता है आपको
travel?
कहना बनता है वो तो यूँ
How long?
धमकियाँ यूँ पाती तो तांगी करती रहती है धमकियाँ देती रहती है मुझे बताएं आपको क्या प्रॉब्लम है दोनों मिलकर शेयर कर दोनों मिलकर सॉल्व कर और शुरू से
How long? A sound wave has a frequency of 2 kilohertz and the wavelength is 35 centimeter. How long will it take to travel 1 point? How long will it take to travel 1.5 kilometer? Problem 11.9. Frequency is given to me 2 kilohertz. I converted into hertz by multiplying with 1000. You know kilo is 10 to the power 3. So when you multiply 2 multiply by 1000, it will become 2000 hertz, which is the hertz is the unit of frequency. Wavelength is noted with lambda, which is given to me 35 centimeters. Centimeter is a smaller unit of length, but we need to convert SI unit system international. Unit of wave length is meter, so that's why a centi stands for -2. If you take it down, it divide this 35 with 100, you will get 0.35 meter, which is the SI, and meter is the SI unit of the wave length. Uh, Length as a unit is meter. Distance is one given to me 1.5 kilometer. Again, a kilo mean 10 to the power 3. So if you 1.5 multiply by 10 to the power 3, you will get 1500 meter. In this numerical, we are required to find time. Time is noted with small t. Solution V is equal to f lambda. This is the formula we discussed in our last chapter. V is equal to f lambda. If you plug in the values, f is 2000, frequency is 2000, and lambda is 0.35. If you multiply by 2000 with 0.35, you will get 700 meter per second. So S is equal to Vt, and T if you say, because we want to find out T. Why we did find V? Because we don't have V in this. We were not given V in the numerical. So first we found V with the help of formula V is equal to F lambda, because we were given F and lambda. With the help of what the things are given to us, we found V is found to be 700 meter per second. So then I use the formula S is equal to V T, or it is separate of T is equal to S over V. S is 1500, S is 1500, and velocity is 700. 1500 divided by 700, if you divide 1500 with 700, you will get 2.1 second. So it is the required result is the time is 2.1 second. So these are the end of the numericals of chapter number 11. 11th chapter is a sound related to sound. So we discussed all the numericals of this chapter from 11.1 to 11.9. The students who joined just now, like students Harun, please give me the feedback. Are you understanding the topics or not? If you turn on your cameras, please students. EU, if you have any problem